Now in substitution, you rewrite one equation in terms of the other variable, and then from the first equation, and then you plug it into the second. So in this case, my system of equations is y equals x plus 3, and 2x plus y equals 15. Well, in this case, I know that y equals x plus 3. So what I'm going to do is plug in x plus 3 for y in the second equation, which gets me 2x plus, now instead of y, I'm using x plus 3, equals 15. And then I'm going to go ahead and solve for x. So this is 3x plus 3 equals 15, and I subtract 3 from both sides. 3x equals 12, and x equals 4. Just like with elimination, you have to go back and solve for the y coordinate. So if I know x equals 4, I'm going to go back to my original equation here. Since y equals x plus 3, I'm just going to say y equals 4 plus 3. So y equals 7. So then the answer here is positive 4, positive 7. And when I check the values, y equals 4 plus 3, I know that 7 equals 4 plus 3, that's true. And 2 times 4 is 8, 8 plus 7 equals 15. So quick check shows that this answer is correct. Now in some cases, you have to do a little work to substitute one term in for another. So in this case, I have 7m plus 2n equals negative 8. 2m equals 3n minus 13. So the first thing I'm probably going to do is take this 2m equals 3n minus 13, and I'm going to divide everything by 2. So I get m equals 3n minus 13 over 2. And then I'm going to take this value and substitute it into the first equation, which gets me 7 times m. Now for m, I have 3n minus 13 over 2 plus 2n equals negative 8. Alright, so I can go ahead and multiply everything out. Notice that 7 is pretty much the same thing as 7 over 1. So I'll multiply straight across using the distributive property. And I get 7 times 3 is 21n minus 7 times 13, which is 70 plus 21, so 91, over 2 plus 2n equals negative 8. Alright, that starts to get a little ugly, but I can go ahead and get rid of this fraction by multiplying everything by 2. These 2's cancel out. Remember, this is multiplied by 2 and this is multiplied by 2. So that's going to get me 21n minus 91 plus 4n equals negative 16. Alright, I have 21n and 4n. That gets me 25n minus 91 equals negative 16. And then I add 91 to both sides. And I get 25n equals 75. Haha, very convenient, isn't it? N equals 3. Now I know that n equals 3. I can go ahead and plug it back into one of the original equations here to solve for m. But you know what? I could also take this n equals 3 and plug it into this equation since it's already set up in terms of solving for m. So I could say m equals 3 times 3 minus 13 all over 2. So m equals 9 minus 13 over 2. And so then m equals, if I hopefully don't run out of space, m equals negative 4 over 2, which means m equals -2. So as I look at my answer here, I have n equals 3 and m equals -2. Now, in this case, substitution was definitely not the easier way to go. In this first example, you could see that it made sense to go ahead and use substitution. In the second example, maybe substitution wasn't the best way. You're going to be given some systems of equations, and you're going to have to decide whether substitution or elimination is the best way to go. So first is your challenge problem. You can solve this by using either elimination or substitution. Elimination or substitution will work. You can do it both ways. One way is easier than the other. In order to figure that out, my hint to you is to first eliminate the fraction and then see what you have left.